Welcome to session 12 of fluid mechanics. My dear students, today we will solve the problems also. Today we will try to learn some theory also, okay, for the module 2. The module 2B, fundamentals of fluid flow kinematics part, and the learning outcomes are the student will be able to describe the flow classification, apply principles of kinematics and hydrodynamics for practical applications. Basic conservation laws like continuity equation will be used. Okay. Now, in the last term, I think I talked about the flow net, which is actually the grid of phi lines and psi lines. Psi lines are called stream potential lines and phi lines are called velocity potential. So, along the psi lines we call stream lines. I have mentioned in the slide as flow channel. The flow will take place, and these two are intersecting each other at 90 degree. It could be curved, it could be perpendicular to each other, but whatever it is, they will intersect orthogonally. Okay. Now, in the flow net, which we described last time as a grid obtained by drawing a series of streamlines psi and equipotential phi lines are known as flow net. The construction of flow nets are very important, and we have some conditions for that. Number 1, the flow should be two dimensional. What do you mean by that? U is a function of x and y, or v is a function of x and y. Definitely we are talking about x and y are two dimension. It could be even y and z, or it could be even z and x, but it could be like a plane. Example, this board is a x axis here and it is a y axis. It is basically a two dimensional, right. If you take the third direction, that will become three dimensional. So, the first condition is the flow should be two dimensional. Next one, the flow should be steady. Steady means, as I mentioned earlier, steady and unsteady flow, they are correlated with variation of flow characteristics with time. What is a steady flow? Steady flow is a flow in which the flow characteristics like pressure, velocity or depth does not change with time at a location. So, at a location if I go, say depth is 2 meter, again if I go 2 meter, after 1 hour 2 meter, that is called steady flow. Is it okay? Then one more condition is the flow should be irrotational. It means the fluid mass is not rotating about the center of mass. Okay, it is going to be a straight line. The flow is not governed by gravity force. The flow is not governed by gravity force. So, these are the different conditions for which we construct the phi lines and psi lines. In that case, we take phi and psi, they are perpendicular to each other. We have methods like analytical methods, graphical method, electrical analogy method, hydraulic models method, relaxation method, Haley-Shaw method. So, these are the 6 methods which are available for the construction of phi psi lines based on the analytical, based on the graphical, based on the electrical analogy, based on the hydraulic models, relaxation method, and the last one is Haley-Shaw or viscous analogy method. Okay. So, these flow nets are very important. They are being drawn to determine so many things. So, the uses of flow net, suppose if you draw a flow net under a dam, you will be able to calculate the seepage, how much water we are losing under the bed. That is called flow net method. So, flow net method is going to estimate your uplift pressure, how much pressure is coming. If my hand, say this is a gravity dam and this is the uplift pressure, it is going to reduce the weight. So, I will be knowing with the help of the flow net, if I am drawing beneath the dam like this, if you want I can show you. This is the gravity dam, uplift will be there like this, water pressure will be there on this side. So, the uplift will be lifting the dam upwards, making it destabilize. So, we will be able to calculate how much quantity of water we are losing out of seepage through the canal, through the hydraulic structure like a gate, like locks, okay. And that seepage estimation is very important, because in the canals we have to leave the water till the end of the farmer wherever in the catchment. So if it is the 55 kilometer length, I need to have minimum some quantity, and if the canals are not lined, then the water will be seeping through the soil. That quantity of seepage I can determine using this flow net method. One more advantage you can see in the slide: velocity and pressure distribution for given boundaries of flow. To design streamlined structure, this is another advantage. And flow pattern near well. You may be having the bore well, you may be having a dug well, you can calculate the flow pattern, how the water is being contributed to the dug well or the bore well in the aquifer, and how to make it. So the flow nets are very important, they determine so many important parameters for us. Is it okay? Now we go to next one. Now we have talked about vorticity and rotationality. It means I would like to know if the fluid mass is rotating about its center. Then you will be thinking, sir, what is this? Now in a river you can see at some places swirl will be there, correct? In the our wash basin also swirl can be formed. There could be a swirl in a mixer also, okay, or mixer grinder, right? So definitely it could be a forced vortex or a free vortex. Question is how to calculate. My dear students, you can see there is an operator called delta operator with the cursor. Del is equal to I dou by dou x, j dou by dou y, and k dou by dou z. I, j, k are the unit vectors. Dou by dou x is the partial differentiation with respect to x. What is the meaning of that? I told you last time also. We are differentiating partially with respect to x only. All other variables and time is going to be treated as constant. If I say j into dou by dou I, we treat the y coordinate or y a variable only is a variable, all others are constant. If you say dou by dou z, I see that we are differentiating partially with reference to z, all other variable like x, y, t are constant. Is it okay? So delta operator is a very important, which is shown in the slide. Let us see the right side of it, velocity vector. Velocity vector V has got three components: u component, v component, and w component. Along the x axis you have the u component, along the y axis you have the v component, and along the z axis you have w component. Okay, the vorticity vector is defined as del cross v. Vorticity is equal to twice the angular velocity. We say vorticity is equal to 2 times omega. You can see in the formula the omega vector has got three variables: omega x along the x direction, rotation along the x direction, rotation along the y direction is omega y, and similarly rotation along z direction is omega z. Then question arises, what is this vorticity vector? Now you can see here vorticity vector is dou w by dou y minus dou v by dou z into I plus dou u by dou z minus dou w by dou x into j and plus dv by dx minus dou u by dou y into k. Make a note of this particular quantity dv by dx minus dou u by dou y. Why I am telling? Omega z is the only rotational vector available in xy system. It means when we say the flow is two dimensional, in that case it is going to be only dou v by dou x minus dou u by dou y. If this value is existing, rotation is there. If this value is 0, we say it is irrotational. So mind it well, the vorticity vector is defined zeta is equal to 0 when all the I, j, k three terms are 0. But for a two dimensional flow in xy direction, we need only omega z to be 0. I repeat, for a two dimensional flow in xy, only omega z need to be 0 for irrotational flow. What is the meaning of flow? It is a straight flow. Okay, if omega z is not 0 for a two dimensional flow, what does it mean? The dou v by dou x minus dou u by dou y, which is the last term in the equation, you can see here this one. If it is not 0, the flow is rotational. It is going to rotate about its Mach center. Okay, if it is 0, it is a straight flow. all the fluid particles are flowing like a laminar flow, one by one, straight line. Is it okay? So this is about the vorticity and rotationality. Let us see a very important term we call velocity components and acceleration. My dear students, the very important is all these formulae, make a note of it, take it carefully. The x component of velocity is u, y component of velocity is v, z component of velocity is w. Repeat, x component is u, y component is v, the z component is w. Then question arises, okay sir, u, v, w we can understand, they are the velocity component. What about the acceleration part? The acceleration is given by a is equal to axi, ayj and azk in the Cartesian coordinates. Ax belongs to the acceleration component in x direction, ay belongs to the acceleration component in y direction, and similarly the az belongs to the acceleration component in z direction. Let us see their formula very carefully. Ax is equal to, we say, dou u by dou t plus u du by dx plus v du by dy plus w du by dz. You can see in the x component on the top you always have u component, u, which is the x component of the velocity. Repeat, x component ax is equal to, everywhere on the numerator you have dou u. You can see very clearly, my dear friends, for x component it is dou u, for x component again dou u. Here take y component, it is dou v, next is again dou v, again dou v and again dou v. Take z component, it is dou w, dou w, dou w and dou w. Is it okay? It means as long as the x component of the acceleration is concerned, we have a term called dou u by dou t, which is called local term. It is called unsteady term. I repeat, dou u by dou t represents local acceleration. Dou v by dou t is the y component of the local acceleration. Then what is dou w by dou t? It is the z component of the local acceleration, right? So dou u by dou t, dou v by dou t, dou w by dou t is a unsteady part, or we can say local component of acceleration. So when we differentiate with respect to time, suppose your flow is steady. What is the meaning of that, my dear students? Everywhere the flow is independent of time. If flow is steady, everywhere the flow is independent of time. What does it mean? Dou u by dou t will be 0, dou v by dou t will be 0 and dou w by dou t will be 0. So if I give a term steady flow, definitely you understand these three terms will not be there in the acceleration component, which is called local or unsteady component of acceleration. Then what is this? Let us see, very interesting. U du by dx, v du by dy and w du by dz. This is called convective component of acceleration in x direction, convective acceleration in x direction. This is ay, convective acceleration in y direction, az, convective acceleration in z direction. How to read out? It is u dou v by dou x, v dou v by dou y, w dou v by dou z. It means these are the components which are convective acceleration in the y direction. That is why everywhere we get v, correct? And if you take the z component, now you can see very clearly dou w by dou t represents the local acceleration in z direction or unsteady component in z direction. What about the convective acceleration terms in z direction? It is u w by dx, dou w by dx, v dou w by dou y and w dou w by dou z. So these formulas are very important. Mind it well, we are going to use in the numerical, but before I go, I will try to give a method on the blackboard how to remember and how to calculate, so that you are not doing any mistake. Okay. Now let us come to this part. As I explained to you, in the u, v, w, these are the three components of velocity, correct. So I would like to ask you, can you calculate the component of velocity at a point, say 1 1 1 example. So x equal to 1, y is equal to 1 and z equal to 1. So we substitute in the formula at any point, say x equal to 1, y equal to 1, z equal to 0, and I say time t equal to 2 seconds. Time t equal to 2 seconds. So we need to substitute and get those respective values here. Whatever values, if I say, for example, if I say u is equal to x plus ty, my dear students, what you will do? Substitute x equal to 1, t equal to 2 and y is equal to 1. So you will get at this position u is equal to 1 plus 2, yeah, you get 3. So u value becomes 3 here. Similarly, you can calculate for v with the equation. Similarly, you can calculate with the w for the equation. So the first step, wherever they are asking velocity or acceleration at the point, please determine those things first by giving those values there. It means, example I have given you, u is equal to x plus ty. So x is equal to 1, you can see here, t is equal to 2 seconds, you can see here, and y is equal to 1. I substituted and I got u is equal to 3 units. We need not write meters per second, we will always say units, that is all. U is equal to 3 units. Okay. So 3 units is there. The next one which we are talking about, the acceleration part. The velocity components are easy to determine. You substitute the values of x, y and z and t in the respective equation, you get immediately those values. You can estimate that without any problem. Is it okay? Let us come to the acceleration part, which is more lengthy and tedious. We will see. A is equal to axi plus ayj plus azk. I told you, no, we come to the ax part. First calculate dou u by dou t, dou v by dou t and dw by dt. It means whatever u expression you got, for example, in this case dou u by dou t will be y, that is all, dou u by dou t. X will be treated as a constant, it will be 0, okay, and t is differentiation of t 1. So y remains, you got this. So dou u by dou t is y. Similarly, you calculate the local derivative for v. Similarly, you calculate v, and again same point, x equal to 1, y equal to 1, z equal to 0 and t equal to 2 seconds. So this value will become dou u by dou t is equal to 1. You can see here, no, this is 1. So we calculate the local derivative very carefully for the x component, substitute those respective values. We calculate for y component as dou v by dou t, again substitute those values. Then we calculate for w component dou w by dou t and substitute. Is it okay? So far what I have told, I repeat. We have done velocity u, v, w based on the equation given to you, substitute the respective value, get the u, v, w. Okay. Sometimes they may ask you the modulus, you can calculate by this formula. V is equal to square root of u square plus v square plus w square. Acceleration, same thing, ax square plus ay square plus az square. So the modulus formula remains the same as in the vector calculus. Now we are talking about u component, v component, w component and local derivative. We have finished. You have finished this. You have calculated dou u by dou t, dou v by dou t and dou w by dou t, substituted the respective points, x equal to 1, y is equal to 1, z equal to 0 and t is equal to 2 seconds. Just for example. Now we are going to calculate the convective acceleration term. My dear friends, be careful, I am showing you a table, you can see here, u du by dx, v du by dy, w du by dz at the same points. Similarly for y component, u dv by dx, v dv by dy and w dv by dz. Is it okay? Similarly for the w component, u w by dx, v dw by dy and w dw by dz. So, once you calculate, we can calculate the complete acceleration values. So, now I go back to the slide, we go ahead, mind it well, we are going to use this in our problems. Let us take the first problem, my dear friends. Be ready with your calculator. Anyway, calculation is not much, you can still work out. The velocity field in a fluid is given by Vs is equal to 3x plus 2y into I plus 2z plus 3x square into j and 2t minus 3z into k. What are the velocity components u, v, w? What are the velocity components u, v, w? Determine the speed at the point 1, 1, 1. Determine the speed at the time 2 seconds at point 0, 0, 2. What exactly it means? He is asking you, first of all, what are the velocity component u, v, w? My dear students, mind it well, the component u is connected to I, component v is connected to j and component w is connected to k. So, if I ask you, you should give me the answer, sir, u is equal to 3x plus 2y, v is equal to 2z plus 3x square and w is equal to 2t minus 3z. Is it okay? Now, we substitute the values, x equal to 1, y equal to 1, z equal to 1 and substitute the value. When we substitute, the time value he is not given. So, you get u equal to 5, v is equal to 5 and w is equal to 2t minus 3. So, if you calculate this wholly for the modulus, which I have shown here also, modulus v is equal to u square v square plus w square, definitely we can calculate. Back in the slide, you can see the slide is 4t square minus 12t plus 59. Number 3, determine the speed at time t equal to 2 seconds at point 0, 0, 2. What it means? Time t is 2 seconds, x is 0, y is 0 and z is 2. So, if you calculate, you can substitute here, you get u equal to 0, v equal to 4 and w is equal to minus 2. So, what is the velocity? 0 square plus 4 square plus minus 2 square, you get some value, and at the same time t is given as 2 seconds. Substitute those things, we get value as 4.472. So, this is the way a simple problem has been done, in which you have been asked to calculate the velocity component, that is u component, then v component, then w component, then the value 1, 1, 1 velocity without giving the time value, we substituted and got the value, and similarly the last one in which x equal to 0, y equal to 0, z equal to 2 and time equal to 2 seconds. So, we got this. Let us take one more problem, an interesting problem. The velocity distribution in a 3-dimensional flow. The velocity distribution in a 3-dimensional flow is given by u is equal to minus x, v is equal to 2y and w is equal to 3 minus z. Find the equation of a streamline passing through the point 1, 1, 1. I think 1 is slightly hidden, do not worry about it, we will take care. So, he has given you the component velocity u, he has given you component velocity v, he has given you the component velocity w. He is asking you to calculate the streamline equation passing through the point x equal to 1, y equal to 1 and z equal to 1. There is no t term here, it is a steady flow, right. Let us write the streamline equation is given by dx by u, dy by v and dz by w. Whatever distance is travelling in the x direction proportional to velocity component u, y direction velocity component v, z direction velocity component w. Substitute those values, dx divided by minus x, you can see here, dy divided by 2y, you can see here, and dz divided by 3 minus z. Now, what we will take? We will take in pair, we will take x and y, then y and z, and then see how it is correlated. Let us take first value, dx by minus x, you can see from here, and dy by 2y. You can see dx by minus x divided by dy by 2y. We can have integration directly because variables are already separated. X is associated with x, y is associated with y. So, 1 by x minus integration is log x, This one is will be 1 by 2 log y, but we get a constant of integration a, where a is a constant. Substitute the value of 1, x equal to 1 and y equal to 1 at the point 1 1 1. Substitute log 1 0, log 1 0, a will be 0. So if you solve this, you get x is equal to 1 by root y. So we are able to take the first two equation dx by minus x, dy by 2y, integrate it proportionately, log x minus log x and half log y plus a. This constant of integration we have obtained based on the point x equal to 1 and y equal to 1. So when you substitute here, you get a equal to 0, we get the equation x is equal to 1 by root y. Is it okay? Now let us take the next part of it. Suppose same thing, streamline equation dx by u, dy by v, dz by w for repetition. Dx by minus x is given, dy by 2y is given, dz by 3 minus z is given. Why? Because u is equal to minus x, v is equal to 2y and w is equal to 3 minus z. Now we take yz part. Last time we have taken xy part. We got some formula. We now take x and z. So dx minus x divided by 3 minus z. If you integrate this, you get minus log x minus log 3 minus z plus b. Now substitute the same value x equal to 1, z equal to 1 and get the value b. You get log 2. So if you solve that, you get x is equal to 3 minus z by 2 by antilog. So if you equate the both, x is equal to 1 by root y is equal to 3 minus z by 2. This is the streamline which passes through the point 1 1 1. Is it okay? Is it clear to you? It's a very simple problem in which variable separables were there. We have integrated once with x and y. We got a formula x is equal to 1 by root y. Then we have gone to the yz side. We have integrated proportionately or accordingly. Then we got the answer x is equal to 3 minus z by 2 as shown in the slide. And then we have equated both the side, x equal to 1 by root y is equal to 3 minus z by 2. So this is the equation of the straight line which we expect. Is it okay? Let us take one more problem. Yeah, it's a very interesting problem. The following cases represent a two velocity component. Determine the third component of velocity such that they satisfy the continuity equation. What is the meaning of that? Two components he has given to you. One component is u, one component is v. He is asking you to calculate or determine the third component based on the continuity equation. Okay, continuity equation, as I mentioned in the problem, dou u by dou x, here dou u by dou x plus dou v by dou y and dou w by dou z equal to 0. There is no time term, right? Now u is given. What is the u value? X square plus y square plus z square. Can you see here? Yeah, u square is equal to, u is equal to x square plus y square plus z square. In the formula we need dou u by dou x. Repeat, u is given. We need dou u by dou x. So my dear students, differentiate this particular equation with respect to x partially, substituting the u. What is the u? Substitute. You can see here, I have written the formula dou by dou x of u. Dou by dou x, u is this value, x square plus y square plus z square. You know, my dear students, if I partially differentiate with respect to x, y and z, they will be 0 because they are as a constant. But x square differentiation will be 2x. So you get here 2x. You can see 2x has come. Similarly, you take the v component, it is xy square minus yz square plus xy. So dou v by dou y of v value, which is substituted here in the equation, xy square minus yz square plus xy equal to 2xy minus z square plus x. So we got the value of dou u by dou x, we got the value of dou v by dou y. Substitute in the continuity equation of 3 dimension. We substitute here for dou u by dou x 2x and this value as 2xy minus z square plus x plus dou w by dou z equal to 0. So if you integrate this, you get minus 3xz minus 2xyz plus z cube by 3 plus function of y. So since we are integrating with respect to z, that is why we write a constant will come as a function of x y. If I integrate with say v, I will get x z. If I integrate with u, I will get y z. Okay. So this is a simple problem which is showing how to convert or how to get the third component if two components are known and continuity equation is satisfied. And what is the continuity equation, my dear friends? Dou u by dou x plus dou v by dou y plus dou z. Is it okay? Is it okay? Right. Next one. This question is again depending on the continuity equation, but different type. Let us read the question. A 250 mm diameter pipe carries oil of specific gravity 0.9 at a velocity of 3 meters per second. At another section, the diameter is 200 mm. Find the velocity at this section and the mass rate of flow of oil. The given is d1, given is d2, specific gravity 0.9, velocity in the pipeline at section 1 3 meter per second, density for water 1000 kg per meter cube is assumed, gamma of the oil will become 0.9 into 1000, right, 900 liter per meter cube. Then V2 we calculate. Now we apply the formula Q is equal to A1 V1 equal to A2 V2. A1 is pi by 4 D1 square, calculate. A2 is pi by 4 D2 square, calculate. We have the formula Q is equal to A1 V1 equal to A2 V2. So Q will be, Q is equal to area which is known, velocity is known, you get a flow rate of 0.1497 meter cube per second. Mass rate of flow you multiply by rho q, rho is the density which is 1000 into 0.1497, you get the answer. And from V2, A1 by A2 into V1, D1 square by D2 square, because A1 is pi by 4 D square, this is pi by 4 D2 square. So pi by 4 cancels, you get this value and you get this velocity of 4.875. Now let us take the next question. The velocity component is given as u is equal to 4 plus 2t, v is equal to 4 plus xy, w is equal to 3xt square. Find the acceleration of a fluid particle at 2,4 t equal to 1 second. Write the formula which we have already defined. As I mentioned to you, first we have to calculate u, v, w at that point. Substitute the value at x equal to 2 here and y equal to 4 and t equal to 1 in this formula. You get u is equal to 6, v is equal to 10 and w is equal to 6. First you calculate, as I mentioned in the board, first you calculate u, v and w at that point. First I told you to calculate u, v, w. Next I told to calculate dou u by dou t, dou v by dou t and dou w by dou t, which is a local acceleration term. Come back to the slide. We see here dou u by dou t at the point 2,4 t equal to 1 second is 2, dv by dt fortunately 0, dw by dt is 12. So please calculate these three terms which I mentioned on the board also. Let us take one more. Now we have to calculate acceleration term. Now you can see here I have divided the whole system. U I know as 6, v as 10 and w equal to 6, which is marked in red, okay, which are values I will substitute here directly. 2, first one will be 6, next will be 10 and next will be 6. Is it okay? Now let us calculate the second terms. Dou u by dou x 0, dou u by dou y 0, dou w by dou z equal to 0. So it is very easy. You can see the u component convective acceleration term is 0 throughout because it is totally depending only on the time. Okay, you can see u is 4 plus 2t. So you differentiate with respect to x 0, with respect to y 0, with respect to z 0. So similarly dou v by dou x calculate 8, dou v by dou y calculate 6 and dou v by dou z is 0. Same way what I have shown in the this board also. I told you to calculate this one. Fortunately it is coming 0, 0, 0. This one you can calculate one by one. It is coming 8, this is coming 6, this is coming 0. So substitute in the formula. Similarly calculate u w by dou x, v w by dou y and w w z by dou z. So once you calculate, substitute in this equation very carefully, Ax you will get as 2, Ay is you will get 108 and Az you will get 30 for the point for which the question has been asked for x equal to 2, y equal to 4 and t is equal to 1 second. Is it okay? Substitute in the formula A is equal to 2i plus 108j plus 30k and calculate the acceleration vector, same formula which I showed here, ax square plus ay square plus az square, this formula. So, we apply this formula to calculate the total acceleration at that point 2, 4 at t equal to 1 second. Okay? So, you can see in the slide we got the answer 112.1 units. Is it okay? Now, let us define very important term called velocity potential. Velocity potential is a scalar function of space and time such that its negative derivative with respect to any direction gives the velocity component. For example, if I differentiate this phi with respect to x, u minus d phi, u is minus dou phi by dou x, v minus dou phi by dou y and w is minus dou phi by dou z. Mind it well, velocity potential is applicable for 3 dimension. Stream function is only applicable for 2 dimension. We will come to that later. The properties of velocity potential are, if the velocity potential phi exists, then the flow should be irrotational. If the velocity potential phi satisfy the Laplace equation, then it represents a possible case of fluid flow. It means continuity equation is indirectly represented in terms of Laplace equation. I come to that. You can see I have derived the Laplace equation. This is the continuity equation, dou u by dou x plus dou v by dou y, dou w by dou z equal to 0. Substitute u as minus dou phi by dou x, v as minus dou phi by dou y and w as minus dou phi by dou z. If you solve, you will get dou square phi by dou x square plus dou square phi by dou y square plus dou square phi by dou z square, which is a Laplace equation, and if it is 0, it shows that flow exists. Okay. One method is you prove dou u by dou x plus dou v by dou y plus dou w by dou z equal to 0, flow exists. Otherwise, if the velocity potential is given to you, apply the Laplace equation of 1 dimension, 2 dimension, 3 dimension, show that dou square phi by dou x square plus dou square phi by dou y square plus dou square phi by dou z square is 0. That is called Laplace equation when the flow exists. Then you may be thinking, suppose if it is not 0, sir, if it is say minus 1, say minus 2, or at the end if I get minus x minus z, then the flow is not possible. When the flow is not possible. So, if it is not satisfying Laplace equation, the flow is not possible. Okay. Let us see one more important term of the velocity potential. It is an imaginary line along which the velocity potential phi is a constant. I think we have already discussed this in the flow net. I told you these are the phi lines and psi lines is the flow line in which the flow is taking place. So, you can see here dy by dx, if you calculate minus u by v, you will get from this formula d phi is equal to dou phi by dou x into dx plus dou phi by dou y into dy. Substitute as per the definition, dou phi by dou x is minus u and this is minus v. If you calculate dy by dx, it is the slope, you get minus u by v slope. I will come to that later also. Okay. Let us see a very interesting relation we call stream function. There is no z function here, only u and v. So, stream function you can see is a scalar function of space and time such that its partial derivative with respect to any direction gives the velocity component at right angles to the direction. It means if I differentiate with respect to y, I get minus u. If I differentiate with respect to x, I get v. Opposite. In the previous case, it was d phi by dy, it was v. D phi by dx, it was u. What is happening now? It is the reversal. So, d psi by dy is minus u and d psi by dx is the v. Very important, by definition you can see, you can equate both the definition here. U is equal to minus d phi by dx and is equal to minus d psi by dy. Similarly, v is equal to minus d phi by dy is equal to d psi by dx. And as I told you, for a 2 dimensional flow, the rotational flow is important when omega z is 0. When it is 0, the value of dou v by dou x minus dou u by dou y we want to estimate. We substitute here v as, from here, d psi by dx, dou by dou x of d psi by dx will become d square psi by dx square. Repeat, dou v by dou x, v is equal to dou psi by dou x, substitute here, dou into dou square, psi remains as it is, dou x into dou x square. Similarly, if you substitute dou u by dou y with a minus sign, minus dou c by dou y, you can see it becomes plus, and you get a very important equation. It is also a Laplace equation of psi. In this case, if it is 0, the flow is irrotational. For a irrotational flow, two-dimensional flow, the elements of z axis must be 0. So, we have to remember this thing. Now, properties of stream function. Lines of constant stream function are psi lines. As I told you, they are perpendicular to each other. We will prove it now. It is an imaginary line along which the stream function psi is constant. If the stream function psi exists, then it represents a possible case of a fluid flow. If the stream function satisfies the Laplace equation, then the flow should be irrotational. Let us go back. These are our definitions. As we will go in the phi case, we will go with the psi case. Dou psi is equal to v dx minus u dy. Along the same streamline, the d psi will be 0. Same, psi minus psi. Psi is a constant, say 1. 1 minus 1, 0. So, dy by dx you get v by u. Dy by dx now you get v by u. Let us take a very important derivation which is called slope for phi lines m1. Dy by dx, as I derived, if you remember, here dy by dx minus u by v, correct? Go back, minus u by v, equation 1. m2, you can see here dy by dx v by u. So, dy by dx v by u. Suppose if you multiply this slope m1 into m2, what exactly you are doing? Phi lines are multiplied with psi lines. Again repeat, phi lines are multiplied with psi lines. We get m1 m2 is equal to u by v into minus v by u, you get minus 1. If m1 m2 is equal to minus 1, they represents phi lines and psi lines, they intersect orthogonally. They intersect orthogonally. It is a very important derivation, mind it well. You have to derive like this. Calculate the slope of phi lines minus u by v, calculate the slope of psi lines dy by dx as shown in the equation number 2 as v by u, multiply both m1 m2, slope of phi line multiply with slope of psi line, you get u by v into minus v by u is equal to minus 1. It proves that the phi lines and psi lines are orthogonal, always perpendicular. It could be rectangular or it could be curved also, right. Let us take some problems on this. For a two-dimensional potential flow, the velocity potential is given by phi is equal to x into 2y minus 1. Determine the velocity at the point P 4, phi. Determine also the value of stream function at the point P. What is given to you is phi. He is asking you the velocity. He is asking you stream function. Okay. Let us go by definition. The velocity at the point P, x equal to 4 and y equal to phi, when phi is x into 2y minus 1. First differentiate dou phi by dou x, which is minus u. Substitute there, u is equal to 1 minus 2y. Dou phi by dou y equal to minus v. Differentiate this one, you get 2x. So, you get v is equal to minus 2x. Substitute the value of x equal to 4 and y equal to phi in the equation for u and v. Repeat, phi is given to you dou phi by dou x minus u, dou phi by dou y minus v, u is equal to 1 minus 2y, v is equal to minus 2x. Substitute x equal to 4, y equal to phi. When you substitute, you get minus 9 and minus 8, and the velocity is minus 9I minus 8j. The velocity vector u square plus v square minus 9 square plus minus 8 square is the answer. Is it okay? Now we will go to the second part. Second part, the stream function. Is it jumping? No. Psi at the point P 4 phi, given is phi x 2y minus 1. What I will do? I will take the definition first. dou phi by dou x is equal to minus u is equal to 2y minus 1, which is given in the question, is equal to d psi by dy. By definition, dou phi by dou y is equal to minus v is equal to 2x, which is given, is equal to, as per the v, minus dou psi by dou x. Now we differentiate, we want to derive streamline, so stream function, so dou psi by dou y becomes minus u, it is 2y minus 1, dou psi by dou x becomes u is equal to minus 2x. Now what we do, integrate the equation 1, this equation with this variable I will integrate with respect to y. So I get psi is equal to 2y square minus 2 minus y plus constant function of x. I have represented here, you can see. Now I am differentiating with respect to x. Mind it, my dear friends, first we will integrate with y, then mind it, we differentiate with x. Reverse, if I integrate with x, then I differentiate with y. Opposite. So let us see this one before I continue. D psi by dy I have integrated with y, right, I got this. I am differentiating with respect to x, dou psi by dou x equal to dc by dx. If I do that, I can correlate d psi by dx as u, and I will substitute here as minus 2x and get the value of c as minus x square. So once you get that, you get psi is equal to 2 cancels here, it's a y square minus y, this c becomes minus x square, we substitute here. So with this way we calculate the psi function from the phi function. Is it okay? First we define here, basically as per the definition, collect term of d psi by dy, then integrate with respect to y, you can see y here, differentiate with respect to x and equate it to u, and then get the value of c and get the answer. Is it okay? I will repeat it in the next question also. A stream function is given, see, in the previous question phi was given to you, see, given was phi, he is asking you psi. Now I will give you psi and I will ask you phi, other way. So determine the velocity and velocity potential at 1, 2. Same thing, definition, dou psi by dx minus v 4x, it is given here, 4x, put the value 1, 2, you get minus 4, minus 8, and resultant velocity u square plus v square 8.94. Again definition, u is equal to minus dou phi by dou x is equal to minus dou psi by dou y. This time it is opposite, we know already the psi, I want to get phi. So I say d phi by dx is minus u, which is dou phi by dou x is minus of minus 4y, and now we integrate with respect to x. Previous case we integrated with y, remember, and differentiated with respect to x. This time integrating with respect to x and differentiate with y. So if you do that, you get the value of c as 0 and you get the answer as phi is equal to 4 into xy. Please follow the same procedure, you will get the full answer. Let us take one more question. Given the components of velocity u and v, u as v y cube by 3 plus 2x minus x square plus into y, v is equal to xy square minus 2y x cube by 3. The condition for irrotational flow is asking whether the flow is irrotational, and condition is dou v by dou x must be equal to dou u by dou y. My dear students, mind it well, we have a condition dou v by dou x equal to dou u by dou y. What is the value of v which is given here? Take it v from here, left hand side. What is left hand side? Dou by dou x of v. V is this equation, xy square minus 2y minus x cube by 3. Similarly, dou u by dou y, what is u? U is y cube by 3 plus 2x minus x square y. See here, if you differentiate left hand side, you are getting y square minus x square. Fortunately, when you are differentiating this u with reference to this y cube by 3 plus 2x minus x square into y, partially with respect to y, what is the meaning of that? We are treating y as a variable, others as constant. So you get same thing, y square minus x square. If they are equal, we say the flow is irrotational. Is it okay? Now, so far whatever discussed, the psi line and phi line, that completes the module 2. My dear friends, thank you very much for all your cooperation, but before I conclude the module 2 and my lecture, I would like to just summarize the module 2. In the module 2, the first part, we dealt with the hydrostatic force F and the center of pressure. You may be remembering, I have given you a formula called F is equal to intensity of pressure into A, which is specific weight of the fluid, into HC into A. HC is the depth of the centroid from the what surface, as I told you, from here to here, what is the centroid that I showed you, into the area. And important thing is center of pressure, HC bar plus Ig, which is the moment of inertia, into sin square theta AHC bar. If it is horizontal like this, theta was 0. If it is like this, theta was 90 degree, and it is inclined at theta at any angle. So, we understood how to calculate the center of pressure and the force for 3 different surfaces. One is the horizontal, one is the vertical, and one is the inclined. Then we entered kinematics. We are not bothered about the force which is causing the flow. We described types of flow: steady, unsteady, time domain, laminar, turbulent, laminar layer wise, turbulent mixing, uniform, non-uniform, distance wise, space wise, incompressible, compressible, density is constant, incompressible, density is varying, compressible for gases. Velocity components and acceleration we have done today, u, v, w, acceleration ax, ay, az, we have done some formulae, the continuity equation of 3 dimension, incompressible flow, dou u by dou x, dou v by dou y, and dou w by dou z equal to 0. We have done a problem also on that, and q is equal to rho 1 a1 v1 equal to q is equal to rho 2 a2 v2. It is the continuity equation in a pipe flow system. And when we described about velocity potential, we talked about stream function and correlation with them. Flow net, I told both of them they cut orthogonally. So, thank you very much. Thank you very much.